Okay, good morning, good afternoon, good evening, whatever time it is, wherever you are. Welcome to this video. Today we're going to be looking at V and M lines, or shear and moment lines, calculating them using the sectional method as a part of the Mechanics 2 and 3 module. So, what are V and M lines? As I said, V refers to internal shear forces. So the forces experienced between the molecules that make up the beam in this example, and the moments that occur due to this. And we can describe them and use graphs to kind of map what they look like. First off, it's important to recognize when they occur and when they change. So they occur between external forces inside the beam, and they change when a new external force is introduced. So here you'll notice we have two cuts. We have a cut 1 and cut 2. The shear forces and the moments are going to be different between cut 1 and cut 2 because the diagram the forces on the free body diagram have changed. In cut 1, it hasn't yet experienced that 5 kilonewton force. Then after it has experienced a 5 kilonewton force, it changes, and so we have to do a second cut, cut 2. This will become more clear as we work through this question. But it's important we recognize this because it tells us how many cuts we need to do. If this had another force, then we'd need a third cut, and so on. So let's jump into it. Where do we start? So in order to start, like I say, we need these two cuts. I'm going to start looking at cut 1. So if we say cut 1, and then I'm going to draw the diagram relating to cut 1. So this is my free body, looks something like this. This represents our cut, this squiggly line. We have this 2.5 kilonewton force. Cut 1 represents really anywhere in between 0 and 2 meters. So between 0 and our next force, which in this case is 2 meters. So this length here is x, where x is less than or equal to 0, greater than or equal to 0 and less than or equal to 2 meters. That 0 is really ugly. There we go. Then the other forces we have is this is where we introduce V and M. So in order to balance this 2.5, there needs to be another force. And when cutting it internally, so when cutting through a free body, what we end up exposing are these internal forces and these internal moments. So we can draw internal force V here, and I'm going to draw internal moment M like this. Okay? Now, we need to calculate V and M. So, as we do with everything, we're going to sum the forces in the y direction. It's statics, so they equal 0. So, we can say positive 2.5, according to my sign convention, minus V, where V equals 2.5. Then we can resolve our moments. Now, if this is point A, I'm going to call this point B. So I'm going to resolve the moments about point B, and they also equal 0. So positive M, because this moment here is in the positive direction according to my sign convention, and it's just called M. So M, then take away 2.5 multiplied by the distance, which is x. So that makes M equals 2.5 times x. So now we can see that our internal shear force is 2.5 kilonewtons, and our internal moment is 2.5 times x, where x is the distance from the left between 0 meters and 2 meters. Okay. Now we have cut 1. We need to do the same thing for cut 2. Cut 2. The diagram now looks something like this. We can include the 2.5, the 5, which we have on our diagram up here. Then we will have our internal force V and our internal moment M. The distance is again a value of x, but this time x is greater than or equal to 2 meters and less than or equal to 4 meters. We also happen to know, due to the free body diagram that we were given in the question, that this length is 2 meters. Okay, so as I said, we're doing the same thing again. So we're going to begin by resolving our forces in the y direction. They sum to 0, and we have a positive 2.5, a minus 5, and a minus v, where v will end up equaling minus 5 plus 2.5, which is minus 2.5 kilonewtons. Then we can resolve our moments, and this is point A. Let's call this point C this time. And that equals, again, 0. And again, we have this moment M in the positive direction, plus, and then we have this 5 kilonewton force. The distance of the 5 kilonewton force from C isn't immediately obvious, but we can still work it out in terms of x. So it's 5 multiplied by the distance, which is actually ends up being x take away 2 meters. So it's x minus 2. Then we have our final force, which is a 2.5 kilonewton force, which is x meters away from C. So it's minus 2.5 times x. Then we can resolve this again to get m on its own. So m will equal 2.5 times x minus 5 times x plus 10. So that ends up with m equals minus 2.5x plus 10. Okay. Now we have a bunch of equations. What do we do with them? Well, this is where the diagram that I've been referring to comes in, because that's what we're about to draw. So we'll begin with the V-line diagram because it's a little bit more straightforward. So if we draw our axes, and on our axes, what we are describing here is the value of the internal shear force over the length of the beam. So the length of the beam in total is 4 meters. I'm going to include the intermediate external force is, which is at 2 meters. And then we have, so this is length in meters, and this is V in kilonewtons. Now, between x equals 0 and x equals 2, cut 1 applies, which means that V equals 2.5. Nice and straightforward. So let's just give ourselves 2.5. So then we go up to 2, because between x equals 0 and x equals 2, V is 2.5. Nice, we can fill that in already. And then between x equals 2 and x equals 4, V equals minus 2.5. So we can put on our axes minus 2.5, and then if we just bring this all the way down, and then this is between 2 and 4, and then we're finished and we can go back up to 0. Because it's statics, we begin and end at 0, and it's that simple. We've drawn the V line already. Now how do we draw the M line? Well, that's also really quite straightforward. To give myself a little bit more room, I'm just going to remove that label there. So M line, then again I'm going to go the 4 meters and the 2 meters. This isn't to scale, but it's close enough. And this is M in kilonewton meters. Okay, so between 0 and 2 meters, the line of M is 2.5x, which means that for every value in the x direction that we increase, the value of the y direction will increase by 2.5. That means, in this example, that for every meter we go along the beam, the internal bending moment increases by 2.5. Now, again, this graph only applies, or this first line, which we got from cut 1, only applies between 0 and 2 meters, meaning that the maximum length we can go is 2. So 2.5x means 2.5 multiplied by 2 gives us a maximum M value of 5. This is clearly a linear graph because it's 2.5x, not 2.5x squared or any other ways it could not be linear. So we're going to begin at 0 and we're going to finish up here. So we can just draw a straight line to connect the dots. And then on the other side, between x equals 2 and x equals 4, we can refer to our second equation that we got from cut 2, m equals negative 2.5x plus 10. And we'll begin by going, okay, well, when x equals 2, which is when this first comes into play, what does y equal? What does our value of m equal? So minus 2.5 multiplied by 2 is minus 5. Then we add 10 and we get to positive 5, which is very nicely where our line is finished at the end of cut 1. What about when x equals 4, which is when we finish this this cut, when we finish the beam? So minus 2.5 multiplied by 4 is minus 10. Add 10, that takes us to 0, which means that we end at 0. This is again a linear graph. There's no x squared, there's no logarithms, anything confusing like that. So we can just draw a straight line between our two dots, like this. Yes, this diagram is not quite to scale. I messed up my x-axis. However, you can clearly see here that this really isn't very complex. I have used my two cuts, where the cuts occur between my external forces, between every external force, to find out the equation of my V lines and the equation of my M lines, and then I've just graphed them. It's that simple. And this is all we need to do for this question. This is the answer to this example. There's a second way of calculating these V and M lines, and that is the graphical method. I will have a separate video explaining that. I hope this helped. Let me know if you have any questions. You can put them in the comments below. You can send me an email, flag me down in person, send me a letter through my door, whatever. Let me know if you want me to explain something in more detail, go over another concept again. Maybe you have a more specific question. But yeah, I really hope this helped. Have a lovely afternoon, evening, day. Yeah, see you again.